So starting with, I think I gave you this question as probably as homework. This is again about drawing a pH curve. Okay, so we're going to try and do this one. Now, one second, let me add people. So this one is again about drawing a pH curve. He's saying write the expression for KW. Remember, water ionizes and produces two ions. One of them is an H plus one. The other one is an OH ion. So somebody's mic is on. So one of them is H plus one. The other one is OH ions. So KW is the ionic product of water. It's H plus one concentration into OH ion concentration, and the H plus one concentration in pure water is 1 times 10 power minus 7 mole per dm cube. The OH ion concentration is also 1 times 10 power minus 7 mole per dm cube. So that means the value of KW under standard conditions, this equilibrium constant, it's 1 times 10 power minus 14. It's going to be mole squared and dm minus 6. So then you've got use your expression, find the value of KW from in the data booklet to calculate the pH of 0.15 mole per dm cube NaOH. Now, NaOH is a strong base. So that means, okay, since it's a strong base, as it's a strong base, what that means is that NaOH ionizes completely. So if NaOH concentration is 0.15 mole per dm cube, then that means the OH ion concentration is also going to be exactly the same. And that would also be 0.15 mole per decimeter cube. So you already have OH ion concentration. So what you can do is you can just substitute in the expression over here, and you can find H plus 1. So H plus 1 would be, like, if you make H plus 1 the subject of the expression, it's going to be 1 times 10 power minus 14, and that's going to be divided by 0.15. That would give you the concentration of H plus 1, which would come out to be what? Can anyone calculate this? Shafa, Karuba, anyone?
6.67 times 10 power of minus 14.
So you're getting 6.67 times 10 power minus 14, right? And they were looking for pH, so you take the negative log of this. I think they were talking about pH. So they wanted you to calculate pH. So take the negative log. What do you get?
13.2.
So the pH we are getting is 13.2. Now it's a pH curve question. Remember, I think this is let's ignore. So we're getting pH 13.2. That's it. Now, the pH of 0.15 mole per dm cube solution of piperidine is 11.9. So suggest why this answer differs from your answer over here. So what's the reason? It has the same concentration. Why is the pH lower? What could be the explanation for this?
Is it because the nitrogen lone pair and the benzene pi electron cloud overlap?
Yeah, but exactly that's the reason. But the main reason is it's a weak base. So NaOH is a strong base. It completely ionizes, so it produces a lot of OH ions, right? If it's 0.15 mole per dm cube, the OH ions would also be 0.15 mole per dm cube. This one is a weak base. That's it. I think. So piperidine is a weak base. And I'm not sure if explanation is needed, but then Mohammed, you'll be right, TK. I mean, you can just on the safe side, you can write the explanation, which is that N has lone pairs. So H plus 1 ions are attracted to this N lone pairs. But I mean, they are attracted to lone pairs. Mohammed, This is not actually benzene. That's the issue. Is this clear, Mohammed?
Yes.
Okay, so I mean, what you said was actually not going to be true. That the lone pair is it's just going to stay there. It's actually its charge density would be higher if you because they're carbon chains. These are carbon chains. Achha, but anyways, so the main explanation is that it's a weak base. That's it. I mean, so the lone pairs of N are not going to attract the H plus one that strongly. NOH is a very strong base, uh, and it ionizes completely. Then, how would you expect the basicity of piperidine to compare? Now, this is the part. This is where we're going to explain that. How would you compare this to ammonia? Now, ammonia also has a lone pair. It has an N, and it's got a lone pair, and the H plus one is attracted to the lone pair. I mean, the arrow should go in the other direction. I'm just showing that the H plus one would be attracted to the lone pair. Remember, arrows in chemistry, they always represent the movement of electrons. So the electrons are going to go towards H plus one. But my point is just I'm trying to show that H plus one getting attracted to these lone pairs. So which of the two lone pairs are going to have more negative charge? This one or this one? What's the effect of carbon chains? These are carbon chains. Remember, carbon chains always have an electron donating effect. So if they have an electron donating effect, the lone pair negative charge density is going to be higher. So there's going to be larger negative charge over here. So the negative charge density on these lone pairs, it's going to be much higher. So I've drawn them bigger now because electrons are getting pushed from the carbon chain to these lone pairs. So there's going to be more attraction for H plus one ions. So it's going to be a stronger base compared to ammonia. So this is the explanation that you're going to write that alkyl chains, they have electron donating effect. Lone pair charge density increases. So its charge density is higher. So hence piperidine is a stronger base. So this piperidine is a stronger base because the lone pair negative charge density is much higher. ठीक है, is this clear? Nabila, Shafaq, Sohail, Rupa, is this clear?
Yes, sir.
Yes, sir.
It's now coming back to hopefully we'll move to this thing. Now what he's doing is there's HCl that is slowly being added. So from the top, there's titration happening. And in that titration, there's HCl. And you've been given the concentration and the volume as well of HCl that's being added. And it's being added to a flask. And the flask over here contains piperidine. It's being added to piperidine. Now, piperidine is 10 cm³ or 0.15 mole per dm³. So there's an acid-base reaction happening. Can anyone tell me what are the moles of HCl? Like how much HCl are we adding? I mean, that's the first part, moles of HCl. 20 into 0.1 divided by 1000. What do you get?
0.002.
So you're getting 0.002 moles. What about the moles of piperidine over here? It's 10 into 0.15 divided by 1000. Point 0015 or what?
0.00150.
So it's 0.0015. And to three significant figures, it's going to be 0. I mean, your answer, the way you're going to write this answer is 0.002, and you're going to add 2 zeros as well. Three significant figures. So piperidine and HCl are going to react in 1:1. This is a base. I mean, we did see that they were reacting in 1:1. Like HCl is going to produce an H+1. Piperidine has the N has only one lone pair, so it's only capable of attracting just one HCl. So or one H+1 from HCl. So it's 1:1. That's the reaction that's going to happen. So which one do you think is in excess, and by how much amount? 0.00150 is going to react with 0.00150, right? So piperidine at the end of the reaction, like when you add all the HCl at the end of the reaction, what's going to be left is 0.00150 HCl is going to react. Can you tell me how many moles of HCl are going to be left at the end of the reaction? Like 0.0015 will react with 0.0015.
0.0005 is the remaining.
So at the end of the day, once you've done the titration, once you've added the HCl, 0.005 moles of HCl,
0005.
0005 moles of HCl are still present in excess. That's the end point. So that's the situation right at the end. So he's saying calculate the H+1 concentration. So we know that how much HCl is left. We know that the moles of H+1 ions are, I mean, HCl is a strong acid, so H+1 ions are going to have exactly the same moles, 0.0005 moles. And he's asking you to find the concentration of H+1. Concentration, the formula of concentration is moles divided by volume. And what's the volume? 20 cm cube being mixed with 30 cm cube, the end volume of this flask is going to be 30 cm cube. So that's going to be 0.03 decimeter cube. So it's going to be 0.005 divided by 30 cm cube. So 0.005 moles divided by 0.03 dm cube. So what's the concentration? And accurate up to 3 significant figures.
0.016.
So we're getting 0.016. What's the third number? Digit after that.
7.
Okay, so it's going to be 167. Remember, all your values are up to 3 significant figures. So your answer should be at least accurate up to 3 significant figures. So mole per dm cube. So you're getting the concentration of H+1 moles divided by volume, and you have to find pH. So just take the negative log of this. If you take the negative log of this, what do you get?
1.78.
So the final pH is 1.78. So that means that at the end of the titration, after you've added all this HCl, you had 0.0005 moles of HCl in excess, and that means the concentration of H+1 at the end, right at the end, was 0.0167, and you took the negative log, you got 1.78. So on the graph, once you add 20 cm cube of HCl, the final pH is 1.78, which should be somewhere over here. That's your final pH. Remember, for the pH curve, you need 3 points. You need the final pH, you need the starting pH. What was the starting pH of piperidine? At the start, there was no HCl. You just had piperidine. And the concentration of piperidine was 0.150 mole per dm cube. So what was the starting pH? Somewhere in the question, they actually gave you the pH. The pH of 0.15 mole per dm cube solution of piperidine is 11.9. So that's your starting pH. Your solution is 0.15 mole per dm cube. Right? This said it was 0.15 mole per dm cube piperidine. So that's already given. That was 11.9. So your flask at the beginning had, so this is 13, 12, and 11.9 is going to be somewhere at this point. So is this clear? The first 2 points, the initial and the end. Is this clear?
Yes, sir.
So what's the third point you have to figure out? The third point is the equivalence point. When does the piperidine get neutralized? Like, you're obviously adding too much HCl. I mean, you're adding, you have 0.00150 moles of piperidine. So to neutralize, what's the neutralization point? How much HCl should have been added? You shouldn't have added 0.002 moles, right? For neutralization, you should have added how many moles? 0.0015 moles of HCl. So we're going to do a bit of calculations, like for equivalence or neutralization. I'm trying to figure out what is the point where complete neutralization would have happened. Okay, we've added too much HCl. We were not supposed to add too much HCl. So 0.0015 moles of piperidine will react with 0.0015 moles of HCl. So it should react with 0.0015 moles of HCl. Now we have the concentration. This volume is incorrect because we added too much of it. So I'm going to find the right volume, like at what volume would there be complete neutralization. So we have the moles of HCl that need to be added. We have the concentration of HCl, which is 0.1 mole per dm cube. So moles is concentration times volume. So using this, we can figure out the volume that is needed to add exactly the right amount of HCl. So what volume are we getting? Is it 15 cm cube? And is this part clear?
0.015.
And we multiplied it by 1000 in cm cube, that's 15 cm cube, right?
No, sir.
No, it's not. Is it 15 cm cube or not?
Yes, it is 15.
So you're getting 15 cm. So that means you shouldn't have added 20 cm cube because you added too much of it. So we found the right amount that should have been added for neutralization so that all the piperidine reacts. So we should have added just 15 cm cube from the top. And that's the point where neutralization would happen. So the right amount of HCl that should have been added. Just a second, I'll go through this. The right amount of HCl that should have been added should have been 15 cm cube. So Zoha, you've got piperidine over here. So I'm just going to say that you have a base and you're adding an acid from the top, and the ratio is 1:1, right? Now the moles of base that you have in your solution, the moles of the base are 10 cm cube into 0.15 volume into concentration. That's 0.0015 moles, right? It's 0.0015. Now, Zoe, is this part clear that we are adding the wrong amount of HCl? We added too much of it. Zoe, is this clear?
Yes, sir. Yes, sir, it's clear.
So that means we're trying to figure out what is the exact volume that should have been added. So I'm going to ignore this 20. I'm adding an acid whose concentration is 0.1 mole per dm cube from the top. And I'm trying to figure out what is the right volume that should have been added, right? So the base is 0.0015 moles. So the amount of acid that must be added from the top should be 0.0015 moles as well, right? So I'm trying to figure out what is the exact volume that should have been added. I have the concentration, I have the moles that need to be added, so I can figure out the volume. So moles is concentration times volume, right? Volume is the only part that's missing, so we can figure out the volume. Zoa, is this clear?
Yes, sir, it's clear.
So basically, we should not have added 20 cm cube. I mean, this is incorrect. We should have just added 15 cm cube. At 15 cm cube, there would have been complete neutralization and the pH would be 7. Is this clear?
Yes, sir.
And after 15, everything, all the acid that was added was in excess. So that made the things acidic. So because when you added 20, you added too much acid. You added 0.0005 moles of HCl in excess. I mean, you added more HCl. You figured out the concentration, you figured out the pH of that excess acid. So if we had added, if we had just stuck to 15 cm cube, we would have reached neutralization point. All the base would be gone and the acid would not be in excess. So remember, you always search for 3 points. One is the initial, the starting, when you don't add the HCl. then the end point when you add all the HCl, and then you find the middle point where you add the exact right amount of HCl, so that neutralization happens. And the curve is going to be an S-shaped curve. Remember, most of the pH is going to change around the neutralization point. So that is where most of your pH would change. So the curve is an S-shaped curve. Okay, I've explained this many times that that initially the pH doesn't change. At the end, the pH doesn't really change. The pH curve mostly changes around the equivalence point when the H+ concentration really goes close to zero, or the base concentration goes very close to zero. That's when the pH changes. That's the maximum. That's the point where maximum pH change happens. So indicator, if you have to select the indicator, remember your task was to stop at 15. At 20, you added too much of it. So the whole plan was to stop at 15. So the indicator should change color when the pH, somewhere in these pH ranges. So it's going to be, I think, 3 to 4 is going to work. Or is it not going to work? It's probably going to work. 0 to 1 is definitely not going to work. 11 to 12, 13 to 14, I think the closest, over here, I think I should correct this. Need to make it more vertical. So 3 to 4 would work, because all the others are definitely not going to work. 11 to 12 is, this is 12, so 11 to 12, the color change would happen somewhere over here. You want the color change to happen when the pH is crossing or close to neutralization point. So 3 to 4 is probably going to work. It's going to change color when you add 15 cm cube of HCl. So is this clear?
Yes, sir.
So then, let's try if there's another pH curve question. Sorry, just a second, let me try and... So over here, they've actually drawn the pH curve already. So this is another pH curve question. This one. So you're saying the first part is, it's exactly the same. Except that now he's talking about ammonia. He's saying pH of 0.2 mole per dm cube NaOH. NaOH is a strong base, so the OH ion concentration is going to be the same. It's going to be 0.200 mole per dm cube. And he's saying use the expression for Kw. So the OH ion concentration is known, and you have to find the H+1 concentration. Can anyone try and quickly find the pH? So H+1 concentration is going to be 1 times 10 power minus 14 divided by
13.3.
So you're getting, and you take the negative log, so pH comes out to be 13 point. So it comes out to be 13.3. So that's one thing. Then he's already given you the pH of ammonia. Explain why this answer differs, because it's a weak base. That's the answer. It's a 1 mark answer, no explanation needed. And no detailed explanation needed. It's just a weak base. That's it. So he's saying at 20 cm cube, now you have to sketch the curve. At 20 cm cube, 0.2 mole per dm cube ammonia was titrated with. So there's ammonia in the flask. It's zero. Can somebody find the moles? Like, how many moles of ammonia do you have? 22.2 divided by 1000. What do you get? 20 times 0.2 divided by 1000.
Zero 0.1 mole.
You can't get 0.1. 0.1?
0.004.
0.004 moles. You get 20 into 0.2 divided by. So that's the moles of ammonia. Now this ammonia has the same concentration, so the pH is already known. He has already given you that 0.2 mole per dm cube. The pH is 11.3. So you know the starting pH. The starting pH is 11.3 because it's 0.2 mole per dm cube. So the question already stated. So that's your starting pH. The flask has ammonia. So 11.3 is going to be somewhere at this point. Now we're going to find how much HCl is he adding. Was titrated with 0.1 mole per dm cube HCl. So actually they didn't tell you how much HCl was being added. Maybe in the next parties, or maybe you just have to assume that you're adding a total of 60 cm cube of HCl, right? So from the top you're adding 60 cm cube of 0.1 mole per dm cube. That's a 0.0004. 20, yeah, I think it's 0.004. 20 into 0.2 divided by 1000, just a second. 20 times 0.2. I'm getting, wait a second, 20 times 0.2. Divided
I'm
by,
getting 4 times 10 to the power minus 3.
so it is 0.004 moles. So it's I think this is right. किसने किया था ये? Abdullah, I mean this one, the first one is right. 0.004 moles. As anyways, you're adding, by looking at the graph over here, the amount of acid added, you're adding 60 cm cube. So it's a 3-mark question. And the concentration is 0.1 mole per dm cube. So how much HCl are you adding in excess? Like how many moles of HCl? At the bottom there's 0.004 moles of NH3. So find the moles of HCl. How much are you adding? Like 60 into 0.1 divided by 1000. What do you get?
0.006.
0.006 moles. So it's 1:1, right? So 0.004 are going to completely react. So once the reaction happens and you've added all the 60 cm cube, out of the 0.006, 0.004 would react with 0.004. So how much HCl is in excess? So the excess HCl would be how many moles? 0.002, right? Is this clear? 0.004 will react with 0.004. So that means you're adding 0.002 moles in excess. And you have to find the concentration of this HCl. So what is the total volume at the end? It's 60 cm cube. This is 20 cm cube. So the final solution is 80 cm cube. So you find the concentration of this acid, divide that by 80 cm cube. That should be 0.08 dm cube. And you can then find the pH by taking the negative log of this. That would give you the concentration of H plus 1. Take the negative log, you'll find pH. What are you getting? Otherwise, is this part clear? Zoha, is this clear?
Yes.
Yes, sir.
Yes, sir.
So 0.002 moles is in excess. Like we've reached the end. You added too much HCl, And the total final volume of the solution would be 60 plus 20 of this. That would be 80 cm cube. So it's 0.08 dm cube. What's the concentration now? And when you take the negative log, you'll get the pH. What's the pH?
pH is 1.6.
So it's 1 point. Let's say it's 1.6. So that's the pH at the end. So you have your starting pH, you have your final pH, and what is the point in the middle where neutralization would have happened? I mean, what you can do is you can ignore 60. Like, what is the right volume that should have been added for complete neutralization? You've got 0.004 moles. So from the top, you should not have added 0.006 moles. You should have added, I mean, 0.00. I don't think it's 20. I mean, from the top, you should have added 0.004 moles, right? You know the concentration as well. That's 0.1 mole per dm cube. All you need to know is the right volume now. Because at the bottom, there's 0.004 moles. So from the top, you should not have added 0.006 moles. You should have added 0.004 moles. You have the concentration. You can find out the volume. So moles is concentration. Moles is concentration times volume. So I think it's going to, volume would come out to be 40 cm cube. Like 40 cm cube was the right volume that should have been added. 60 cm cube was too much. You added, I mean, that was 20 cm cube extra that you're adding. So is this clear?
Yes, sir.
Yes, sir.
So at 40, it's going to be completely neutral. Okay, you should have stopped at this point. You went along, you kept on adding acid, and the solution then became acidic. So your curve would be sketched. I mean, it's going to be vertical, maximum vertical or pH change happening at this point. And this. So it's that's your pH change that's happening over here. Is this clear?
Yes, sir.
Yes, sir.
In this question, actually, what basically in this specific question, TK, what I suspect is that because they didn't give you a grid line. So I mean, maybe I need to check the marking scheme because you don't have to do such detailed working for this. Probably it's just a hunch. Because you already knew the starting pH. They gave you the starting pH. That was 11.3, right? There was no point actually trying to figure out the final pH. All you had to know was that it was going to be acidic. Like HCl is a strong acid, so it's going to be acidic because even if you try and figure out that the final pH is 1.67, you can't really show it over here. And there's not enough space available. They didn't even give you space after that. So there's no space for working. So you could have just figured out the final pH that you're adding too much acid, so it's going to be very acidic. So you'll just show that it's acidic. The only thing you had to figure out was this thing, that at what point will the curve cross the neutralization point. So probably there's no marks for finding the final pH. You could just sort of guess it because even if you find it, there's no room or there's no place where you could actually state what the final pH is. You just had to sketch it. So that was one our effort in trying to figure out the final pH that wasn't probably required in this question. It was just required that you know that it's going to be very acidic. And they were looking at the shape of the curve. When would it turn? When it would become vertical. So the next part is you have to find the indicator. So I think the best one is going to be this one. Probably is 6 to 7.6 is the best. That would work. Like 6 to 7.6. It's right over here in this area. 3 to 4 might be too close to this side, so it might change color over here somewhere. This might change. This was 11.9. So anything that's close to 11 is not suitable. So 8.3 to 10 is also not suitable. 6 to 7.6 is very good. And then he's saying, let's do just the last part. The solution containing NH3 and H4Cl acts as a buffer. Explain with the help of equation how this is behaving as a buffer. So same question. You've got an acid, which is NH4 plus 1, and you've got its conjugate base, which is NH3. Like, I mean, this is the reaction. NH4 plus 1 is capable of releasing NH plus 1. And NH3, on the other hand, is capable of gaining an H plus 1 to form NH4 plus 1. So you've got this reaction. What would happen if you add H plus 1? The buffer would neutralize it. Who's going to neutralize it? The conjugate base or the acid? What's the answer to this? Anyone? Shafaq, Zoha?
So could you repeat the question?
Like if I add H plus 1, if I start adding H plus 1, so what would be the reaction? You've got-
NH3 plus H plus 1 gives you NH4 plus.
So NH3 is having those lone pairs. It's the conjugate base. It's going to accept all those or attract the H plus 1 ions. So that's your reaction. So he's saying show the equation. So that is what's going to happen. The next part is if a base is added. So now you're starting to add a base. So you're adding OH ends now. So now who's going to neutralize the OH ends? It's NH4 plus 1. That would release an OH ion, not an OH ion, it would release an H plus 1 ion. Give it to OH ion, neutralize it, it would turn into water and NH3 would be formed. So is this clear? The two equations. The acid gets neutralized and the OH ions also get neutralized. Okay, is this clear?
Yes,
Yes,
sir.
sir.
So you can try going through, it's a big worksheet, try and do as many questions as possible. Most of the questions are kind of, I mean, we've already done, even in the class, we did all types of questions, like you get 2-3 different types of questions. It's either pH curves, it's either the buffer question, or it's a weak acid question. Or they might ask you about the explanations for whether an acid is weak or strong. So we're going to move to case P in the next class now, tomorrow. Okay? So everyone, let's continue tomorrow. Take care.
Thank you.
Allah Hafiz.